Hello, today we're going to be talking about similar triangles, and I'm going to try to, by the end of the day, you should be able to say, I can show that triangles are similar triangles. So first thing we're going to do is talk about how we can know if two triangles are similar. Now, if these are similar triangles, what we do know is that their angles, corresponding angles have to be congruent. This angle has to be congruent to this angle, and finally this last angle is congruent to this last angle. All right, now if they're similar, uh, the sides we said were proportional. So this side times some value will give us this side. This side times some value will give us this side, and this side times this value will give us the third side. So let's give some names to these vertices. So if these are similar, then AB over DE will be equal to BC over EF, which is equal to AC over DF. So if we can prove this, and show that all the angles are equal, the corresponding angles are equal, then we know that the triangles are similar. So now what if we have a little bit less information? What if we just know that, if we just have the sides? Well, the first thing we need to do is check and see if the sides are proportional. Is 5 over 2.5 equal to 13 over 6.5, which is equal to 12 over 6? Well, that's 2, and that's 2. So all of those equal 2, so all of the sides are proportional. Now, is that enough information to tell us that these angles are congruent? That's a big question for today. And the answer to that question is yes. Because if we have the sides of all three sides of the triangle are proportional by side, 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 we know that these triangles are similar. So we don't need to know all of these angles to prove similarity. Now, proving triangles are similar is very like proving that triangles are congruent. You remember SSS? The one difference is in the congruence chapter, side, side, side meant all three sides were congruent. All three matching sides were congruent or the same size. Now they have to be proportional. So let's look at this. Are all three of these triangles similar? So 9 matches up with 5, so 9 over 5, 12.6 over 7, and 14.4 over 8. Now if I divide each of those, 9 divided by 5 gives us 1.8. 12.6 divided by 7 gives us 1.8. 14.4 over 8 also gives us 1.8. So since they all equal 1.8, by side, 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 we know that these triangles are similar. Now, this is all the work that you'll need to show that these are similar. All right, now what if we just knew two angles? If I take these two sides, two angles, first off, am I able to find this angle? Hopefully you said yes, because all three angles add up to 180. 180 minus 90 is 90. Subtract 35. That would be 90 minus 35, which should give us 55. If we do the same thing here, 90 plus 35, subtract from 180, we'd also get 55. Now, as we blow this triangle up from a small triangle to a big triangle, or if we shrink it from the big one to the small one, if these angles keep the same size, we know that these sides have to be proportional. And we know this, we just say AA, because all you really need is two angles. If you put AAA, that would be fine too, but the minimum you need is two angles in a triangle to prove that the two triangles are going to be similar. Now this says, why doesn't AA work when we're proving triangles are congruent? Well, if this would be a situation where these two triangles are definitely not the same size, but the angles are corresponding. The corresponding angles are exactly the same size. So um, it works when proving that they're similar, but not for congruence. Now these are the three main, we didn't talk about side angle side yet, but side angle side also works. These are the conjectures that work for, um, for proving similarity. There's only three that we have to remember. Now, can we say that these triangles are similar? Well, 12 would match up with 9, so 12 over 9. Does that equal 8 over 6? Let's take a look. 12 over 9 is 1.3 repeating. 8 over 6 is equal to 1.3 repeating. So since those are the same, we have two sides that are proportional. Now we need a third, an angle or a third side. We don't know what these sides are, but we do know that these are vertical angles. So since we know that, by side angle side, we know these triangles are similar. Now this one, we're not given any side lengths, but we have these two vertical angles. And a tricky part, since these two are parallel, this is an alternate interior angle with this angle. We could have similarly done this angle and that angle, but since we have two angles that are congruent, the angle-angle conjecture will tell us that those two triangles have to be similar. Now in this one, we don't know any angles. We have a small triangle and we have a bigger triangle. Now we have, the tough part in this is matching up the correct values. Let's take the biggest angle in the big triangle, 36, or biggest side, I mean, and it's going to match up with the biggest side in the small triangle, which would be 24. The smallest side in the big triangle, which is 24, is going to match up with the smallest side in the little triangle, which is 16, and the medium side, 30, is going to be over 20. Now if I divide these, or divide these, I'm going to get 1.5 each time. So by side, 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 these triangles are similar. Now in this case, I have side, side, and an angle. Side, side, and an angle. Now this angle is not in between the two sides, so this we cannot prove because it is a side-side angle situation. And side-side angle does not work for similarity. Now we're done with the lesson. So we just did the first one, proving that similar uh, triangles are similar. So rate yourself on a scale of 1 to 5, how comfortable you feel with that. And hopefully we can move on to the classwork and homework. Good luck.